Welcome to Atmosphere Notes. We are in Learning Target 3, and we're going to be learning about atmospheric composition. So we've already been learning about solids, liquids, and gases, and our atmosphere is made up of gases. So what are some properties of gases that we have? Most of our gases are colorless, they're odorless, and they're tasteless. They're all around us, you can't see them. We also learned that gases are a form of matter. It has mass and it takes up space. We saw that with the example of the balloon. We were able to blow up a balloon. We could get the mass of it before and after. And finally, gases expand when hot and contract when cold. When we say they expand, they get bigger and they spread out, and when they get cold, they get smaller. So take a look at your note sheet. Under the brainstorm section, there's a question I want you to think about. What do we use our atmosphere for? Try to list as many things as you can down in that section for what you would use your atmosphere for. After you've listed your brainstorm section, turn and talk to a partner. What activities happen in our atmosphere? Generate another list to add to that as well. And finally, taking a look at what we use our atmosphere for, answer the last question. What might happen if we change our atmosphere? Generate a list. So why is our air a gas? There are some components of our atmosphere that you can take a look at this chart. They have a really low boiling point. So if you take a look at the values that we have for nitrogen and oxygen, which make up a majority of our atmosphere, you can see that they have a really low boiling point. That temperature is extremely cold, which means if they're boiling, they're going to go from a liquid to a gas. So that's why our atmosphere spends majority of its time in the gas state. So question for you guys. Is our atmosphere a solution, a suspension, or a colloid? So a little bit between them. A solution means that it's a mixture of a bunch of different things together. A suspension means that if we were to leave it sit for a little period of time, some pieces might kind of settle out to the bottom. Like if you were to mix dirt and water together, you might eventually have the dirt settle at the bottom. And a colloid is kind of like a suspension, but the droplets might be a little bit bigger and floating around in there. So what do you think? A solution, a suspension, or a colloid? If you chose that it was a solution, you are correct. Within our atmosphere, those gases are evenly distributed throughout. So what are the main components of our atmosphere? So you might have guessed it correct. The first one that makes up almost 78% of our atmosphere is nitrogen. Most people think that our air that we breathe is mainly oxygen, but in fact, 78% is nitrogen and 21% is oxygen. All the other components after that are a little bit smaller. So we have argon at 0.93% and carbon dioxide at 0.033%. In addition, if you were to do that whole entire math, not quite 100%, so we do have other trace components mixed in. So which gas do you think is the most important to humans? Hopefully you said it's oxygen. We need oxygen for all of our cellular functions within our body. So flipping your paper over, we're going to start talking about the layers of the atmosphere. So layers of the atmosphere. The first layer to the atmosphere is called the troposphere. So on your paper, what you're going to do is you're going to label troposphere on your picture. You're also going to use color in addition to describing what it is. So the troposphere, as you can see in the picture down here, is the layer that is closest to Earth. We live within the troposphere. It's also the part where all of our weather takes place within the troposphere. After the troposphere is a layer called the stratosphere. So go ahead and label stratosphere, and inside of the box, you'll be able to write that the stratosphere contains our ozone layer. Our ozone layer helps block those UV or ultraviolet radiation from the sun. That's where you need to be wearing sunscreen because our ozone layer doesn't always do the best job and oftentimes will let in some harmful rays. So sunscreen is important to block out some of those UVA or UVB rays that cause harmful burns within our body. The mesosphere, or the middle layer, meso means middle, is our mesosphere. This one is our coldest layer that helps slow down meteors. You can see there's a little meteor in the center here, so maybe you want to highlight that on your drawing. And then finally, the last layer, the top layer, is called the thermosphere. The word therm means temperature, so it is our hottest layer, and it also blocks deadly radiation. So another question for you guys. We're going to start learning about trends within our atmosphere. And so my question is, what happens to the temperature as altitude increases in the troposphere? Basically saying, the higher that we go up into the sky, what happens to our temperature? Does it increase or does it decrease? Maybe we can make a prediction based on this image here. As altitude goes up, what happens to our air temperature? You guessed it, temperature decreases as the altitude increases. So I've got a quick video clip to show you guys.
If mountaintops are closer to the sun, why is it always colder up there than it is down here in the city? Well, please consider the following. Our atmosphere is thin, but it's thick enough to keep us warm. Now, when you're wearing a coat like this one, it keeps you warm because it holds air next to your body. The same thing with the atmosphere. There's more air above us when we're down here in the city than when we're way up here in the mountains. So it's like the world's low places are wearing more coats. They're wearing more air than these places up high in the mountains. And as you travel up through the atmosphere, it gets colder and colder because the air gets thinner and thinner until you're up around 10 kilometers. That's when you leave the troposphere and enter the stratosphere. Anyway, the rate at which it gets colder is called the lapse rate. And it's about 5.5 degrees Celsius per kilometer. So a mountain, say 3,000 meters high, let's see, that's about 10,000 feet, would be about 17 degrees Celsius colder than it would be down here in the city. And that's plenty cold enough for there to be a spring shower in the city while it's snowing up in the mountains. Thank you for joining me on Consider the Fall.
So hopefully you had a pretty good representation of what happens as our temperature decreases and our altitude increases. So what happens to the air pressure as you go up in altitude then? So down here at the bottom where you might live is high pressure. Up top here is low pressure. So air pressure decreases because you have fewer air molecules above your head. Down here, think of gravity as pulling all those air molecules down on top of you, so creating a little bit higher pressure, where up top you have less air molecules and lower pressure. So make sure you are filling out your trends in your atmosphere on your worksheet. So the last one we need to talk about, what happens to the gas composition as you go up in altitude? When we mean gas composition, we mean that mixture of nitrogen, oxygen, argon, and carbon dioxide. Does that mixture change as we go up in altitude? So another little image that we can look at right here is we've got these convection currents. So if you're down here at the ground, we always know that hot air rises. Okay, it cools because we said the temperature is colder as you go up in altitude, and so that cold air is going to sink right back down and warm back up. So what these are called is they're called the Coriolis effect. And so to answer our question about the gas composition, we would say that it's evenly spread throughout the atmosphere. So whether we go all the way up high or all the way down low, there is no change in the atmosphere as we go all the way up to the top. So hopefully you had an opportunity to learn a little bit more. Flip the page over. You're going to make some predictions. So a good opportunity for you to finish some sentences, to talk about the trends, and then add a picture that helps you learn the information a little bit better. Have a great day. Thanks, guys.